Yo. What's up, everybody? I'm feeling kind of sad because today I learned about the news of someone from the Socrates community passing away. He's a very young person. Yeah, I mean, we don't really have that stuff happen a lot, I don't think. At least not that I'm aware of, at least. Yeah, I was thinking about maybe not showing that, but I mean, you have to pay tribute, and tribute is due. So ja, Ton. Ton is gone, you guys. No, at least he doesn't have to struggle anymore. Oh, really sad. Fucking hell. No, I'll drink to that. Skål. Yeah, so I don't know what the last time was or when the last time it was that I posted another video or live stream for that matter. Looks like it was day 7 and now I'm at day 11 basically. So there are some solutions in between. I'm not sure if they will be worthwhile going over, but let's just do that before we get into day 11. So day 8. Which one was day 8? Ah, yeah. So this is the one where you were getting different signals to these segments. So to represent a 1, instead of getting C and F, you were getting A and B, for example. And then we'd have to deduce if, what the actual signals were and like to which segment that they belong to. So for a 1, it was quite easy because if you had one signal pattern, they called it, that has only A, B, then you knew that it had to be the 1. So, but then you still didn't know, is A and B, is A equal to C and B equal to F, or is B equal to C or A equal to F? So to do that, you have to do some different stuff. But if you combine the 1 and the 7, so for the 7 there are also exactly three signal patterns, so you would know that which one was a 7 and which signal pattern was a 1. And if you combine those two, you really can distill that the top one. So the A1, that's the one that's different from both the 1 and the 7. So the way that I solved that was by first looking for, I think, 1 and 7. So distilling this one or deducing this one, the A segment. And then I would just add up all of the pattern signals I got. So I didn't really care which they were, just that they were. And then if you added, or I found that if you added the signal pattern for 4 twice, then every segment would get a unique number. So my code ended up looking like this. You just get all of the encoded digits, then add 4 twice, because we knew what an encoded 4 meant. And then replace all of the signals you would get for the A signal, so the top segment, And then you just group by it and count it, and then we knew all of the 8s are a B, the 10s are a C, this is a D, E, F, G. And then you have a decoder, or you can build a decoder with that thing. And then once you have a decoder, you can just feed it all of the displays. So that's the second part of the input that you get, because first you get all of the different signal patterns and then the actual display that they wanted to show. So it's always a combination of either one of these and then that 4 times basically. So yeah, that's what my code looks like now. It's deduce a decoder out of the signal pattern that you get, and then use that decoder to decode the encoded display that we got, put it in an integer, and then we were good. I ended up writing the decoder builder, but I didn't really need it. I think we actually stopped our stream of day 7 with this one, but I didn't complete it. So then on what happened on day 9, day 9 was problematic for me. So we had to have another grid somehow. It's called a height map, and every integer here is a depth basically, or a height, and the lowest heights surrounded by higher heights are the bottoms of basins. So in that example input, we've got the basin for the 2, or that starts off with the with the 1, and then 1 higher than 1 is a 2, and 1 higher than 2 is a 3. So all of these, and then 9, it's not higher, or it didn't count, and this 9 also didn't count. So the basin is basically the 1, 2, 3 over here. Same goes for this one, where if you start from the 0, next to it is a 1, a 2, and then a 1. Next to this 1 is a 2 and a 2, and also the 9, so the 9 doesn't include. Here again there's a 2, a 3 next to it, and a 9 here. So all of these things are separated by 9s. And the thing I mistakenly assumed was, if you look at this basin, or the test input for these basins, is that every basin you can deduce if you just look for the one next to it that has exactly 1 higher. So for the 5, exactly 1 higher than 5 would be 6, and there is 1. So then you would go to the 6, look for exactly 1 higher there, you'd find these 7s, and exactly 1 higher to those, you would find these 8s, etc. But the actual input also contained examples where you'd have, for example, a 5, and then here a 7, and then here maybe a 6 or something, I don't know. But in any case, my assumption was incorrect. So what happened is my test input was working, but my actual input was not. And that's really a scary situation to be in, because you don't have a clue on what's actually wrong. And I eventually went into the Kotlin Slack, looked at the thread for day 9, and then found that someone was having exactly the same problem as I was. And then they mentioned that be careful, the test input says that it's exactly one higher, but that's not the case for the actual input. So once I knew that, it wasn't easy. I just had to change this filter expression here, and then I knew which one was belonging to this basin. Yeah, and it wasn't really difficult to accumulate the basin, so I end up accumulating it until you don't have any possible next basin points basically. And the next one is determined by looking for the current basin, excluding the basin you already have from that, because, for example, if you look at the 6 here, the 6 already has 7s over here, but then if you go to this 6, it would also find this 7, and you don't want to count that thing twice, so that's why I always deducted the basin we already had from the found possible next basin points, because here we would just look for all of the neighbors using the height map, and then we'd filter on only fetching the neighbors that are of a higher height. And then we would know where the smoke flows, basically. That was the thing. So that's the main thing we had to write there. And then we can construct a basin. Then I did some experimentation because I noticed that when I was using these tiles at using map, so using a map to figure out what the tiles are, if I would do this, then it would take me 38 seconds for the complete solution. And I ended up using the locations with a lazy association or associate by, so as a map. And when I did this, it turned into 0.3 seconds. And if I use the list with lazy, I would get a 3.5. So I ended up keeping this one and then keeping the stats for the list implementation. Then day 10 was basically becoming a compiler or a syntax checker. So for every opened parentheses or any kind of open character, it has to close with the corresponding closing character. And initially what you had to do was find all of the corrupted lines. So those were the ones where you expect one closing character, but you found another one. And then you had to do some calculations, like if you found on one line a parentheses, it would be 3 points. For a square bracket, it would be 57 points, etc. So this one was not that difficult, but that one I immediately had the correct abstraction for that, because I immediately created a syntax error sealed class containing a corruption, and a corruption knows how to calculate its penalty points. So the only thing I needed to do was figure out what the expected and actual were, and these I had to come up with because of the way I used my I wrote my test. Oei, nee, cancel. So I wrote my test first, and I wrote it like this, so that it really followed the assignment. So we had you can have a corruption with an expected and an actual. So it's a corruption with an expected and an actual. And then since I had the expected and the actual, I could just use that to count the penalty points for that. And then part 2 was basically, instead of just finding the corruptions, also find auto-completion basically. So if there's a string and it's just unfinished, there were no illegal or corruptions there, then just find what the actual result should be. And I think that was solved for me by accident. Why was that again? Yeah, because the way I did the compilation, or I implemented it. So just keep the different openings and the different closings. I check if the current character is in openings, and just add them to their corresponding closing that you expect. And then once you do that, you go to the next one, etc. And then if you encounter a closing character, basically, that's the else expression. If you encounter a closing expression or character, you need to check that it compares or that it is the last expected. If it's not, then you throw the corruption. Otherwise, you do remove last. So you just drop the last character and then your expected array shrinks again. And then finally, if none of this stuff ends up causing a corruption, you end up with a list of expected closing tags, which we just have to reverse and then create an auto-completion with that. And I also, even though the assignment didn't really say that I had to do that, if by any chance you had a string that's just correct, then we just return null and then there's no syntax error. And then syntax error itself is a sealed class with two different possibilities. Either you've got a corruption or you've got an auto-completion. And that was day 10. I think day 10 was a really fun one. I was not looking forward to implementing that because I tried it before in my life and I didn't like doing it. It's so bleh. But now it was fine. I could write it nicely. And then before I start the explanation of the flashing Dumbo octopuses, taking another sip of this heeborrel. This is heeborrel. It doesn't actually look this radioactive. It looks way more like this. So it looks a bit like a banana liqueur. And I think it is a type of liqueur. It's very sweet, very syrupy. And it's really delicious if you freeze it. You put it in your freezer, just like you would, what's it called? A Jägermeister or that kind of stuff. It's really, really delicious. Right, so how do these Dumbo octopuses work? So first of all, these things exist. They're called that way because when they move around, they seem to use their ears to fly around, basically just like Dumbo from at Disney. You might or you might not know them. They're apparently typically found at the deep, deep sea. So this is why they're called Dumbo octopuses. Now I don't know if they are bioluminescent, but in the puzzle they are, or they can flash basically, and they've got some kind of energy. And if an octopus flashes, so when they drop to level, or no, when they are at 9, the next step will happen is that they will flash, and the moment that they flash, they basically do an area of effect type of thing, where all of the adjacent octopuses end up having their energy level raised as well. If because they flashed, or if because their energy level also got raised and they turn into, or they exceed 9, then they also end up flashing. So somewhere below at the bottom, yeah, here in this case. So you only have a bunch of octopuses of 1, and then one in the middle that has an energy level of 1. And it's completely surrounded by octopuses that are about to flash. So what will happen in one step is all of these will flash, and in turn will increase the energy level of this center one here. Yeah, and then the ones surrounding it as well, of course, but more importantly the surrounding one. So we've got the next step that will happen, which brings all of these to 0. this one to 0 as well. Well, no, this one to 2. And then they all start applying their area of effect effect. They've got, so that's 1, 2, 3, and that's 8. So 2 plus 8 is more than 9, which is 0 in fact. And that means that this one ends up flashing as well. But you would think, ah yeah, but then if these all turn to 0, and so if this one turns into 0, the middle one, and this one does that as well, then how come this one remains 0 instead of having or being 1? And there's a constraint there, and that the one that is that when you have already flashed in one single step, you don't flash anymore, or you don't actually increase anymore, is what it's saying here. What does it say here? First, the energy level of each octopus increases by 1. Then any octopus with an energy level greater than 9 flashes. So I guess we can consider either 10 being more... how do you say that? We maybe need to give them an energy level higher than 9, for example, and then do the drop to 0 after they flash. This increases the energy level of all adjacent octopuses by 1, including octopuses that are diagonally adjacent. This causes an octopus to have an energy level greater than 9. It also flashes. Continues as long as new octopuses keep having their energy, so new octopuses keep having their energy level increased beyond 9. An octopus can only flash at most once per step. Finally, any octopus that flashed during this step has its energy level reset to 0 as it used all of its energy to flash. Adjacent flashes can cause an octopus to flash on a step, even if it begins that step with very little energy. So that was the case I just explained. And this is in fact the case that I've got in my tests already. So we've got that exact one. I already did the after second step. So after the first step, it should look like this. And then when we step this thing again, it should look like that. So my tests are currently failing. Let's run them, in fact, and have another drink. Damn it, I can't believe it now. It's so fucking young. It's a good thing I brought up backup alcohol, huh? Fucking hell. So, after Heiborrel, we are drinking the last beer in the Brussels beer project that I got from Sinterklaas. It's the infamous Delta IPA. No. What does it say? Some bullshit. Fruity exotic notes. Anyway. Let's have a sip. Well, you can taste the IPA much more in this one than I could in the other one. But that's quite okay. I have no idea why we're getting a no such element exception. No such element. There isn't a max of then. Is that what I'm reading? Maybe it might be empty, in fact. Okay, that might be true. Why is that? Because octopuses... Okay, I have to think about this problem again now. It's the issue. Ah, yeah. So I looked up, of course, how do you call a group, a cluster, a school of octopuses, a collection. And one article I found suggested to call them a consortium, which I found really nice. So I stuck with it. And a consortium of octopus we can create using this constructor that has a string. We just pipe that as to this constructor here, where you've got a list of strings, which just turns that thing into a map of points. Oh wait, we don't need this. Of points, and for every point you've got a Dumbo octopus there. And what's a Dumbo octopus? This thing, well, it has a point, an energy level, and then an amount of flashes that it has. I don't know why I was keeping this part, because I might just keep a boolean for this thing or something. I don't really know yet. And then increase energy. I think this is why. So when we increase energy on a Dumbo octopus and the energy is equal to 0, then we say it flashed. So I don't think we want to do that. It's not great. I think what we should do probably is say that it flashed when its energy level is above 9. And then we just need to reset them or something, have a reset function. I think that'll be a bit easier. It's also following more the instruction or the text we found on Advent of Code more. So let's write it like that instead. So this should still be a boolean. And we flashed when energy is larger than 9. Or maybe we should do should flash or something. Is about to flash. Or flashed. Flosse? Let's see if we can get away with that. And then the increase should just be... Do a fucking increase, my man. I think we can inline this. Return that. And then convert it to an expression body. What's the problem here? There's no greater than. We could ask energy if it should flash or something. I don't really know why I did that. Yeah, it's because I had an energy data class that then understood when you keep on increasing it and you extend 10, you increase more than 10, then you drop down to 0 basically, but that's not what I want to do anymore. So energy, ye gone. Energy will just be a uint now. Yeah, voila. Increase, we just need to do... Is there a plus plus on that? We can't actually do that. Huh? +1 U. So Then I bet we've got other uncompiling shit like this thing. So, and finally, it's happened to me. No, this is just another compilation error or something. Cool, cool, cool. So what we do in one single step, we shall fold X amount of times. Still don't know why I'm writing it like this and not doing, I don't know, a for each or whatever. Don't care. I think it's because I want to pass this as an accumulator and then don't care about the actual steps here. Then finally, I think we are missing one thing, because we also need to keep the amount of total flashes to put in our final maybe what we can do is make that a no, we're creating a new consortium every time in our step anyway, right? Yep. So for every step, I think we should just keep the amount of flashes that we had in one step. So let's keep private eval amount of flashed octopi. It's a uint that starts at 0. 0u. And then here we should probably, I don't know, increase that at some point. We will see how we will do that. First, let's just have another drink because we need it. Let's put these things on new lines, huh? It'll be a little bit easier to read. Okay, so let's look at the code, what we're doing. All of this bullshit is just parsing. And then we enter a step. And the first thing we do in a step is, well, we define a loop function, but we want to create a new consortium after that step. That makes sense, huh? By doing this loop here. So this looks like we're doing recursion. A recursive call. Hooray. Oh, I think we should probably put that thing at the back. Then if affected points is empty, we'll just return our accumulator. So the thing we just passed out, the current octopuses. These affected points are gonna be, maybe we should put that, make that affected octopuses or something like that. And we start off by just getting all of them. Just put in all of the octopuses, all of the points. If it's empty, then you can just return. Otherwise, we'll have to calculate what the affected octopuses are. And so initially we'll fold over all of the affected points. Pass along the accumulator itself to this thing. So this octopi, which is, yeah, it's a map, huh? and then it takes the affected point as well as a second parameter. And what we'll do is here, I think, because we want to figure out what are all of the affected octopuses. So I don't see yet a way to increase them other than this thing here. So we check increase energy, or what we will do is we will map them so that we can increase their energy basically, right? And we only want to do them where the points match. So initially it's just all of them. We just increase all of their energies, get new octopuses back. Then we check which one of you flashed. We find these, and then what we'll do is we'll just find all of their neighbors, list them as flash affected points, right? And then we will loop again using these, the flash affected points and the affected octopuses. Now I don't really know why I make the distinction between these. Because this seems to be reducing them all, I think, eh? Both the accumulator and no, so these just stay like that way. Yeah, so this is just having them increased again, and it's all of them. That's why it looks a bit weird here because we're doing a filter, but this is basically saying fold on all of them. So do something to all of these points, but only do something if they match this, and otherwise you just have to return unchanged octopi for the ones that didn't match these keys. Cool. And then you pass these along. And well, you do that until there are no more neighbors to be found anymore. Now, what I want to check is for all of them that flashed, that's these ones, find all of their neighbors, which should return points, and then loop again. And basically keep on doing that until you have no more flash affected points. But so that's why it's really important that once they go past a point, or once they go past an energy, that we need to set some boolean that they have flashed. Otherwise, we run into an infinite loop. And this makes sense, I think. So we just keep on increasing their energy. Voila. And that's cool. So you always have them as flashed. And then here, I think what I need to do before I return them. So if I put these in new or stepped octopi or something, I don't know, stepped consortium. Then what we need to do is reset all the ones that are at 0 or higher than 9. So that would be another fold, I guess. Or it's a reduce. Wacht, stepped consortium reduce. We can't do that. Or it's again map values or something. Nee, what we can do is do filter keys. Nee, not filter values. We need to do filter values where we do it dot flashed basically. Only get these, and then map values where we say we don't care about the key, we care about the value. Value just reset or something, reset energy, or maybe exhaust would be better because they spent all of their energy. So let's do exhaust. This returns. Oh, maybe I need to. No, it's just that's the way we need the map. So we'll return another Dumbo octopus by doing that, and we'll say energy equals 0u. That's resetting. Val reset consortium. Do we need to do something else still? I think that's it. Let's run it. Let's run the tests. By the way, I'm playing this playlist that includes a guy called Marketway. He's a very enthusiastic lo-fi beats creator, or I don't know, artist, musician. I'm gonna play his song again, I think, because it's really nice. Yeah. Can you do that? Ming. Add to queue. Maybe if I do that, it will be played next. We'll see. I still don't know why the no such element exception is going off. Oh, it is in fact working. Okay, I'm just gonna shut up for a while. Enjoy this as I debug this crap. All right. If I interpret this error correctly, the toString is going off because my assertion is trying to go off, and it's trying to display this consortium here to do the comparison. And so apparently there's something wrong with my toString method that I wrote, but I don't know if the no such element exception, it's like where it is in fact. So we can try to do that if I just do this first, consortium.toString. If I put a breakpoint here, we can see if that actually just works. But yeah. It should output the same thing in any case. Looks like the toString is working though. So, yeah. Or not. Oh yeah, we don't print it, so that's why. Pardon, we can't actually see it. So that seems to work just fine, so I'm gonna remove that. But then when we end up in the step function, what the verbanelings? It just explodes. Try this step once. I'll do this step here. And we should end up here, so let's try to find out what's going on there. Let's rerun it in debug, I think, yeah? Maybe what I can also do is fix the toString. Say if octopus is empty or something, then we can't do this. Alrighty, let's get into so initially just push down the complete list of points there and the current octopuses, which is the same thing, yeah? But then with the octopuses we go inside of the loop. What the fuck, banelings, dude. Start consortium is empty. That really means that this I don't get it. Let's debug it again. So I want to go inside of this loop. If you press enter, you're out of there immediately. Maar dat kan toch niet, dude? Let's put the breakpoint here then, I guess. Okay. Affected points, it's 25. Voila. Then what? We try to fold our octopi. And after that happened, apparently it didn't affect any... What the fucking... What is it? It's a point. And a point... It has to be the same though. Is point not a data class? It is. Based on X and Y. Cha. The other thing, I mean, we could rewrite this, I think, is if instead of doing a fold, we could also do just this. Right, because map values returns a new map. Yep. So I could also just get rid of this carp. Just fold on ak. Young. Where my key is in affected points. It's the same thing really. At least I think it is. Affected octopuses has been affected. Yeah, these are not the actual affected. This is all of them. Yeah, initially it's all of them. And then what? Then we check the ones that flashed, which are 8 of them. And then what? Then we find all of the neighbors. We still just find 8. Yeah, it's all of the neighbors of the one in the middle, in fact. Then we loop. Why affected points is now 64 all of a sudden. Why is that 64? We probably want to put that into a set, don't we? Or is this why it was important to loop over all of the affected points? Because these end up being the flashed. Okay. So just find all of the affected octopuses. but it should be a single one, right? So is this 64 of the single point? No. It's all of them somehow. That doesn't seem correct, huh? Oh, I didn't see this part here. So I bet I'm blowing my stack. This because it'll never reduce, it just increases in fact. Kill it. Okay, so initially it's all of them. I think that's fine. Huh? Then we find all of the octopuses basically that we want to change, which is all of them. We increase their energy. We don't change anything to... What does map value do? A new map entries having the keys of this map and the values obtained by applying the transform function to each entry. Preserves the entry iteration order of the original map. That's fine. So then we get the affected octopuses now, which is all of them. Then we do filter values, just check the ones that have flashed basically. So returns a map containing all key value pairs matching the given predicate. The return map preserves the entry iteration, blah blah blah. So this, it can't be that they all flashed. We saw that we had 8 here, huh? But then what? And we checked for all of the neighbors basically, or all of the original neighbors of the one, so that's 8 of them. We find all of their neighbors to then also affect them, which is correct, I think. I don't, that's the issue. We don't filter out the ones that already have flashed. So do filter values or filter. Oh, we can't do that here. Wait, we already did that. It's this point. Yeah. That's also why I wanted to do it X amount of times. I wanted to impact. That's why I looped over all of the affected points, because it's those that I want to increase, not the ones that end up matching, because then I do it once. So this was incorrect. So we still need this, I think. So I want to say for all of these affected points, yeah, it should be like that. Find a single one that matches this affected point, the one that you're looping over now, and then increase its value or its energy and then return that as an accumulator. So it should be okay. I should keep on doing the octopi, and then eventually I'll return this updated map containing all of the affected octopuses. Maar jong, waarom werkt dat niet? Godverdomme. Allee. Initially, we've got all of them. Then let's step inside here. Don't know how to actually do that. Step inside apparently. But the affected octopuses ended up being 0, which is unbelievable to me. So let's do drop to frame again or something. Here, young. Run it again. Put the breakpoint there. Where do I want it? Line breakpoint, and then we can check what the fuck this point is. So it's at 0, 0. Yeah, it makes sense, it's all of them. So you're telling me that if I do octopi filter keys with 0, 0, I can't find a single octopus or what? You what, mate? Ah, wacht eens. Now I understand why. So this is fine, of course, but I'm not actually building up the accumulator anymore here. So the last affected point will be nothing. It can't find it, and then the map values is going to return an empty map. That's why. Okay. I gotcha. It's okay. I guess I can just map all of them and yeah. Okay, I'm gonna do that. So I'm gonna combine the map values. So only do increase energy if the key matches affected point. Else just return V. Voila. Don't know what's happening here. Let's just run it because confidence. You might end up in an endless loop now. Oh yeah. Okay, so at least it's better than getting 0. I don't know. Anyway, so when we increase, or when we have increased that energy, then we want to check who flashed. That's all of these flashed octopuses. Ah, yeah. So So we need to find a way that they only flash once, because otherwise they just keep on affecting each other, I guess. That's why I was keeping the amount of flashes. So how the hell am I gonna do that? We need to find a way to determine if it's flashed this round and if it has flashed or something. Okay. And then we just say what we could do here is the moment we increase and it's higher than 9, then we set this to true. If we increase it again, then we just set it to false. We can do that, right? Then let's try that. So let's convert it to a block body. Here we will say, wait, I don't think we need flashes. We're not using that anyway, so get rid of that. So flashed this step, we should probably set it to something like that, and set it to false. Then here what we can do is check the new energy here. Like that, and then we set flashed this step if new energy is larger than 9 and energy before was less than 9. So I guess if new energy is exactly 9. Okay, so then we can also just set it to exactly 10. Okay, and then what we can do is make our flashed this step into not not a field. Well, a field, but not a parameter. I would just set this to exactly 9 or exactly 10. Yeah. Because if it's well, you can. Yeah, that's incorrect. It's not correct, I don't think, because you can be affected multiple times by your neighbors, so we can't just do that. Fuck. We could also just keep its energy at max 10, for example. So if you keep on increasing, that's fair, eh? Then we just block it at 10. So maybe you call this max energy or something. That effect, then we might need to keep an energy class anyway. You don't have a copy, so create a new energy of 10, else energy of value plus 1. No idea why I wrote that as a let expression. Is just stupid. So now it reads, if value is at 10, then just stay at 10. Let's put this in max or something. Yeah, I have that stuff here as well, but maybe we can just say is maxed. You can't have extra Then let's make it into a data class. I think we did the same kind of stuff last time. We can just return this, in fact. Yeah. So what I want is this constructor, but really I want another main one. That has an energy. And then we can say this point and energy of energy. These no longer need to be vals then. Oh, it's because it's the same thing. And energy is not a data. It's not a. It's a value class. Then we can put a data class in that stuff instead and turn this into a property. That should fix it, right? Oh. Needs to turn into an increase. Ah, yeah, and here we need to say energy reset. Okay, so what we're doing now is saying there's a flashed this step property, which just delegates to when energy is maxed, quote unquote, basically above the 9. Fucking hell, I don't remember where I'm going with that. It's the same, huh? Like that. Just go check them. Did you flash this time? If we remain at 10, then We've got the same issue, I know. We cannot make the distinction between flashed this step and flashed before or something like that. I guess what we want to do is these are the ones that flashed this step, so for all of those we want to find the neighbors. That's what this thing does. But then this is the accumulator. It's okay that that changes. But then next time we'll go over those neighbors again and we check, hey, did you flash already? Then don't increase your energy, basically, huh? Is that correct? Why is this so hard? Godverdomme zeg. I think what I could do is look at this and then map them, saying flashed before or something after I do this part, because it's important. That this is one operation and that every octopus, well, a single octopus gets affected multiple times. So up until 10 then, I guess, whatever. And then we say, yo, all of these flashed octopuses, did you flash this step? If yes, return all your neighbors. Who have already flashed then? Yeah, it's not because you already Maybe what we can do is when we say flash affected points, get rid of all of the ones that already have flashed or something. Yeah, I think we need to do that. So we'll do find all the neighbors. So instead, maybe what I want to do so these are all of the neighbors. Then I need to get rid of all of the neighbors that have already flashed. So how can you do that? If I subtract non-flashed neighbors or something. Let's do flash effect points, which is just all of the neighbors minus fucker. Flashed octopuses. Yeah, basically these, and then the keys. So yeah, okay, that means we'll have to do this, and that's it. Let's see it now. Nope. Kom igen. So we found one affected point. Oh, nee, all of the affected points we found. Then we say increase all of their energy. That's nice. Then find the ones that have flashed this time, and flash this time means, are you at max energy? And you can get at max energy if you're at 10, basically, huh? So all of the ones at 9 will move to 10. So that's all of the octopuses that are filtered now. Then we go check which one of you flashed this step. So that's all of the ones at 10. For every one of those, we find all of their neighbors. And we subtract the ones that flashed. So that's excluding themselves. And these gets put into the loop again, along with the accumulator, basically, yeah? Then what? Then we check, are you empty? No. Why not? Because we just found a bunch of neighbors that need to be affected. That's great. But that means that we keep on... Yeah, nee. So we keep on increasing those that got affected. Then we check again, did you flash this step? Ah, yeah, and we keep on getting the same octopuses that way. We don't reset. That's the issue. Yeah, I guess we could reset the ones that flashed this step, I think. or like have flashed already or something. So these are the ones that are in accumulator. Filter values flashed this step. Yeah, maybe what I should do is map values and then say if flashed this step, well, then you return, wait, fuck, it needs to be KV, so it's gonna be V. I don't think we will do anything with the point. So, something like that. We can just do mark as flashed before or something, huh? And that would be so for this one, we just check both flashed already, so not flashed already, and your energy is maxed. So maybe we'll do first energy is maxed and you haven't flashed already. Yum. So we want mark as flashed already. This is fine. I think we just want to do this and then pass these mark. Oh, fucking hell. If we do this over here, then we are also good, huh? And then if we say mark flashed already, then we actually say flashed already, but I also want to say flashed this step is false. So this we need to also add somewhere in the increase. So we'll do the increase. Put it on multiple lines then, I guess. And then here we'll say flash this step. And then we'll say flash this step equals flashed test, apparently. Can you do that? Voila. I guess here the exhaust will also, we can also put that inside here. So Hola. Now we're getting actual assertion errors. If octopus is empty, return nothing. No consortium. So the energy to string, we need to update that to string. Just return value. You've got 10 here, so they're not being reset. Yeah, maybe conditionally exhaust would be if your energy is at 10. Yeah, I think. Why do we need that though? You don't need to check if they already flashed, right? There's no conditional exhaust, you just need to exhaust them all. Well, no, I guess it's conditional because you have to be at max energy. And reset does... Okay, maybe we say reset from max? Something like that. And then we don't need this part in there. And here we just say, again, if is maxed, else this. At least now it's being set to 0. But they're being only calculated once, apparently. So now it seems like our loop is not working anymore. So it's not inside of the increase. That must mean that they get dropped with these affected points here. And the flash affected points means yeah. Help! Help! Do I debug again? I guess there's no choice. It's a difficult problem. It requires more beer. If you ask me, yeah. Alright, initially we've got all of the affected octopuses, that's nice. Yeah, great. And then how many of those flashed now? It should be 8, which is all of the neighbors of the middle one. Well, fuck me, it's 0. So we increase the energy. Then we check. Are you now at 10? That should be good. Then you also check, you should not have flashed already. Because if you have, then... Uh-huh. Which is initially set to false, right? It's not like we're creating Dumbo octopuses with true somewhere, eh? Like a dumbass. No, it's just false, okay. But so why is it that you can't find any of them? Let's rerun the debug. See, this is already incorrect then, huh? Because when you're at 10, you should have flashed this step. Hoe kan dat nu? Oh nee. It returns an energy. I was afraid that we might use a different constructor or something that but that's not the case. Because energy returns an energy. And we say what flashed step is. It must be this one. So, oh, I'm so stupid. Better. Okay, then let's go back to where we were. Was that here where we did minus flashed octopus? Is that keys? Be right back, I'm gonna get a beer. Yo. Alright. This time I got myself an actual Karmeliet. School. None of you geniuses have figured it out in the meanwhile. Let's debug again. So now it should be 8. Yeah. And then what should come out of this? Let me tell you, it's not 40. Or maybe it is, in fact, I don't actually know. Let's figure that out. Allee. So, this fucker's neighbors. 1, 2, 3, 4, 5, 6. I think. So 1, not this one. 2, not this one. 3, 4, 5, 6. Yeah. Then this neighbor. 1, 2, 3. No, no. 4, no, no. So 3 plus 6. Should put that somewhere. Yeah, this should also, wait, why is, no, so it's 6 plus 3, 6 plus 3 plus 6 again, that's the first row. Then these haven't flashed, huh? So then this one, it should be 1, 2, 3, no, no, 4. So that's 4 plus. This one hasn't flashed. That's this one I'm talking about here. This one has flashed. It's also 4. Then it should be this one, which should be 1, 2, 3, 4, 5, 6. So it's just like this stuff before, which leads us to 6 plus 3 plus 6 plus 4 plus 4 plus 3, 6 plus 3 plus 6. Oh, it's 39 in fact. Still more than I thought. You've gotten off by 1 then. Or I missed something, eh? Yeah, I missed 2 of them because this one in fact has 1, 2, 3, 4. 5, 6. Yeah. So this makes more sense. So that's 4 times 4, which is 16, plus 6 plus 6 plus 6 plus 6. That is indeed 40. Allez, holy crap. So all of these points need to... So that's correct. Okay, great. See, this is why I can't trust myself with math. That's cool. So that's at 40 here. And it's already flash affected points, eh? Nice. Oei, wat nu? Great. Then we say, just do that. Yeah, actually, I want another breakpoint here because I want to figure out conditionally mark flashed already, what that actually means. So what is ACK? Do we have things that are mark flashed already? We should have them, huh? Yeah, voila, kijk. So they have flashed already. What the hell is going on, young? So we try to increase the energy of those neighbors again. And then we check how many of those flashed this step. It should be none of them, huh? But now, in fact, all of our... So the affected octopuses, these should now have their correct energy levels, hè? Zie, dat klopt hier toch, godverdomme. 3, 4, 5, and then the ones at 10. And then we say, how many of you flashed this step? Wait, we can check that again. It should be 0, hè? Ah, godverdomme. We don't reset, that's why. Okay, let's stop this stuff. I guess what we should do then... So they are maxed and they have flashed already. So that should put this thing to false, no? How come they're not put to false? They're not included. That's why they are not included. But even if I... Yeah. Yeah, I think what I should do is do that here. I think this is important still though, right? That happens, but here I should also set flashed this step. I put them to false. Flashed this step is false, and then flashed already to true. Let's run it again. So it's working, but my Dumbo Octopus consortium itself, I don't know. keeping the amount of flashed octopi. What's the problem? So now they're not equal just because the amount of flashed octopi is incorrect. You can't see that because the toString is not incorporating that. Something like this. Voilà ça. So now the annoying part is that we can no longer express that in our assertion here. So what I think I'll do is just say 9, comma, and then here we still keep at 9, comma, right? Because none of them flashed after the first one. Here, I guess it should be 0, comma. And then what I'll do is keep this thing. That's this one. Don't give it a default. Pass it along. And we should adapt our second constructor to that as well. Voila, and then we should be good. Or not, because it should be a U, and a U. Rerun. God, jongen. Fuck. Wat nu weer? Oh yeah. So that's correct, because we want to know how many flashed in a step, and here it should be 0. Unless we will... Godverdomme, wat is toch nu weer? Okay, I don't think it's going to... Oh yeah, okay, that's probably why. Sorry, zeg. Then we no longer want a default, I don't think. Or do we? No, I think we still want to increase them. So in here it should remain 9. But we need to make sure that it counts twice. And we haven't done that yet. So we want this thing to be increased. The... What's that? This dot amount of blah blah plus these. In step. And then I think I'll want to move the dot to uint here. Voila. Rerun de tests. I don't know what the hell is going on. Is uint not comparable or something? Show me your equals. No, we would have ran against that problem much earlier, huh? What? Ah, Annie. Oh shit. It's a value class for an int. Why byte? Not byte, I don't want byte. Scratch. It's exactly the same. Is it because map is not comparable or something? We have different maps. Do we use the copy somewhere there? So let's make it into a data class or a regular class then. And then override equals and hash code. I am Confucius! What if we get rid of the toString impl? Yeah, so data classes bring that along with them, so let's get rid of that. Pardon. Here's market way again. Enjoy! Click to see difference. Oh. Fuck. Yeah. Okay, that makes way more sense. Okay. Yeah. I guess we just do the toString on these fuckers then, cool. toString, that's the only thing I care about, is equal to the thing I had before. That also means that I can get rid of these again. It's a painful painful thing to do. So if you override if you override the toString, you can be in a world of hurt if you so get rid of that. 9. Voila. And we want to save here. I guess we'll also do trim indent on this fucking thing then, or what? So what's this? Spaces. Why are there spaces? Cancel. So now I don't want to overwrite the toString, and then I'll just use as string over here. But then I don't know what I can do to is it because of this one? Oh, no. So the new lines are fine, eh? Apparently it adds a bunch of spaces. What does trim do? Leading and trailing white space removed. I mean... What if we do that on all of that? That's also very strange because this should be white space as well, right? It doesn't seem to be getting rid of that thing. Fucking hell. So the S string we'll keep, but then can we do equals is equal to ignoring white space, something like that? I want to smash something. Oh yeah, what? Why is it 18 now? So if we step again, it's not flashed already, it's flashed this step. So it's either that or just return flashed already in total or something. You fucking hell, what's going on? You fucking muppet. This might be it. This might be it. This is it. Now to run the test input. wait, no. First, move all of the production code, which is all of this crap. Fucking, we wrote so much. Into day 11. Amount of flashes. Fudge. We just need to say now. Make a Dumbo Octopus consortium from this input. Nice. And then we say step 100. I don't remember how many times. And then get is it a private? Of course it is. Get the amount of flashed octopi. So, let's fucking go. Let's try it out. Pray with me. Man, I'm so sick of this this puzzle. The reason why it confuses me so much is because I had to solve it with the fold. Oh fucking hell! Now it's 100. We're not even done yet. Wait, maybe it wasn't 100. What's the actual thing? Should be 100. Ja, maar wacht eens. Yeah, I think it's this is just still incorrect. So when you step, we need to increase it, eh? We need to increase it. It's just not correct, this part. The flashed already thing only counts within one step, so we need to reset. So we say conditionally exhaust. It's on these that we also need to reset their flashed, well, all of the booleans basically. So maybe we shouldn't do copy here and instead just create a new Dumbo octopus using the same point and then resetting the energy, and then by doing that also resetting this here. Let's rerun the regular tests first, maybe? I don't know. Is it gonna be helpful? Me. Ah, yeah. So how come? Yeah, it's after the first step. Oh wait, it should still be at 9 though, right? Oh yeah, so here they get reset. So I need to do this first. Why is it that I need to do it on the reset? That doesn't matter. So here it's just a count anyway, so I'll just do that. And then I do want to increment that. So it's the current amount of flashed octopi plus this one. Voila. Oh my god, green. And then this one, green, please. Please, 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 please. Yeah, it's green. It's green. We might finally solve part 1 of day 11. Oh my god, no. Oh wait, what, really? This seems not enough. Fuck! It's correct. Oh my god. Let's commit. My god, yeah. Push it. Now what? The individual flashes aren't bright enough to navigate. Seem to be synchronizing. What? The first step during which all octopuses flash. So now it's loop forever until a condition. Okay, maybe we can do that easily. So we'll create another Dumbo Octopus consortium with the input. And then we just say assign this fucker to that thing. We'll reassign it. Now it's not amount of flashes, but it's amount of steps, which can be an integer. And then what we can do is while Dumbo Octopus Consortium amount of flashed octopi is not its size. Now maybe we can just say all octopus synced. Just keep stepping. And then yeah, maybe also increase a counter somewhere. So we'll do step counter equals 0. We'll do step counter plus plus or something. And then we just do step counter. Yeah. This should be a boolean, and we can say this is true when amount of flashed octopi, well actually octopuses dot size dot toUint is the same as the amount of flashed octopi. Godver. Okay, and if we do that with a test input, it's after step 195. So in our test, let's run it. Wait, is that correct in fact? 195, oops. Okay, I'm stopping this. We'll do also println step counter. And then we'll also do synced octopi. Well, no, flashed. Ah, fuck, Emma. It's not that they're flashed at the same time. They need to have all the same number. Or the same... Okay, that's probably why then. So this is all of the octopuses. Oh, it's a key value. So we don't need the key, we need the value. It's when they're at 0? Energy equals energy. Or is it just coincidental? Will all flash simultaneously. So it's not just synced, it's all octopi flash simultaneously. Okay, let's see it. Fine, just rename the tests. Yay. Let's run it with this. We know that 195 is incorrect, Emma. I guess I'm gonna get rid of that also. 403. Please let this be correct. Oh my god. We fucking finished day 11. And then I heard that 12 was hard as well. Oh, like as well. Day 11 should not have been this difficult, honestly. Let's push it. I guess I just screwed myself with that recursion. Time is 10 o'clock. Fuck. Passage. Oh yeah, this is the graph problem. Great. I think I might skip this one. The only way to know if you found the best path is to find all of them. Fortunately, the sensors are still mostly working, and so you build a rough map of the remaining caves. What if a Balinks? Start A, start B. This is a list of how all of the caves are connected. You start in the cave named Start. Ah yeah, okay. And your destination is the cave named End. An entry like BD means that cave B is connected to cave D. That is, you can move between them. So the above case system looks roughly like that. You start here. You can go to A, or you can go to lowercase b. And then from lowercase a, you can go to B itself, that's this line. You can also go to C, that's here. You can also go to end, that's this one. And you can go to B, from B to end, that's this one. And B also leads to D. Your goal is to find a number of distinct paths that start at start, end at end, and don't visit small caves more than once. It would be a waste of time to visit any small cave more than once, but big caves are large enough that it might be worth visiting them multiple times. So all the paths you find should visit small caves at most once and can visit big caves any number of times. Given these rules, there are 10 paths through this example cave system. Where you go from start to A, then to B, then back to A, then to C, then back to A, and then to the end. Each line in the above list corresponds to a single path. The caves visited by that path are listed in the order they are visited and separated by commas. Cave D is never visited by any path because it starts from a B. So if you would go there, you return back, then you would hit cave B again, and you cannot visit cave B more than once because it's small. How many paths through this cave system are there? It visits small caves at most once, so given these rules, basically, yeah. Yeah, I don't know how to make graphs. We did that last year, I think, with a weighted graph or something. I think that was different, huh? A weighted graph. Solve 2. Oh my god. This scallop is such a cheeky bastard, yeah. Did they put it here in comment, maybe? Allee, let's read this thing again. It's a node and it has a weight. So if you create something with these nodes, you can assign a weight to it. You can find nodes to a given node. So from start to end, basically. And maybe when we can say the visited nodes, I guess those stay. Nodes to visit is empty. Yeah, this is an optimized path because you get a single path to from one node to the other, I think. Well, what other graphs do you have? Yeah, maybe if we follow this one. Count number of ways to reach destination in a maze. The fuck? 3 is destination. So that's 0 base then. Yeah. Why is it called GFG? We don't actually have blockages, eh? That's the other issue to be using this. Or I guess we could, yeah, a blockage is a dead end when, where was that, here? C and D, no, actually only D are dead ends, because B cannot be revisited, but A can. Non-obstacle block exactly once. Yeah, it's not a grid, huh? It's a graph. Yeah, a node may be visited twice. To avoid processing a node more than once, use a Boolean visited array. Cool. Fucking hell, I hate it when they just describe it like this. I really, really hate it. What in the actual fuck am I even reading? Input n equals 4. What the hell is n? Is it the amount of nodes? I don't know. E equals 6. What the fuck is E? Fucking hell, man. Depth first from vertex 1. There they say input n is 4 equals 6. It's the same but different arrows or something? I don't know. So it's just keeping the nodes, but that takes the index of the node and the visited array. Mark the current node as visited, print the node. Traverse all the adjacent and unmarked nodes. Call a recursive function with the index of the adjacent node. So yeah, add edge. So once we have like transforming the input into edges, I think we can do, because that's all of this basically. And here the other input looks like that. Those are edges. And then what we need to find is paths. That visit small caves at most once. So these are paths that start at start and end at end. So if we, that's already a limitation then. If you the 19 paths through it are as follows, because you might be revisiting those bigger caves multiple times. So. And what is breadth first then? Ah yeah, you cannot visit yourself again. I guess it's just an order or something. They go from 1 to 2 and then 1 to 3. I can't make any sense of this. I'm sorry, I'm really just too stupid. The pair is ordered because UV is not the same as VU in case of a directed graph. Yeah. The pair of the form indicates that there is an edge from U to V. The edges may contain weight, value, or cost. Graphs are used to represent many real-life applications. Graphs are used to represent networks. Networks may include paths in a city or in a cave system. Graphs are also used in social networks like blah blah blah. Each node is a structure and contains information like person ID, name, gender, locale. Okay. The following are the most commonly used representations of a graph: an adjacency matrix and an adjacency list. There are other representations also, like incidence matrix and incidence list. Choice of graph representation is situation specific. It totally depends on the type of operations to be performed and ease of use. So an adjacency matrix is a 2D array of size. It's a V times V, where V is the number of vertices in a graph. Let the 2D array be, and then it's just pseudocode. Removing an edge takes, what's that thing again? Log 1 time. Queries like whether there is an edge from vertex U to V are efficient and can be done. Consumes more space even if the graph is sparse. It consumes the same space. Adding a vertex is blah time. And a list is equal to the number of vertices, and then let the array be in blah blah blah. It can also be used to represent a weighted graph. Maybe we should go back to our code thing here and then look for where weighted graph is used, because I really don't remember. It's even generically typed. Absolutely no idea. Oh wait, day 10 exercise 10 maybe? This does not look like the graph. Huh? Some cleanup. Day 7. Bag rule. Oh, now I remember. It's with that bag you had oh fuck. Day 7. Ermergerd. How did that work again? So you had a bunch of bags and you had to find which color got to the gold bag first or something like that. And one bag could contain other bags or something. And we are saying that bag rules is a weighted graph of color and amount. Why are there still mosquitoes in the winter? Please explain. Bitch is dead though. The issue with this thing is that you can't really see how it's implemented because it's in my test, I think. That's why this year I'm all of my solutions contain the parsing of the list and then the actual call. So here we are creating a bag rules of it, but then we don't see like what the solution actually is, because it might be that we call traverse down multiple times or something. Don't know. So we're changing it into a mutable list, then adding edges, and then doing recursion on this one, I guess. Can't make any sense of this. Young. So we know that we can solve it by putting all of this in some kind of a graph. But then how many paths through this cave system are there that visit small caves at most once? So we need to make the distinction between big and small caves in our graph. And then get rid of all of the paths. Well, just generate all of the paths. Just generate all of the paths from start to end. And so that's an issue. Like, how do you know when you're done finding them all? Honestly, this is above my pay grade, yeah. This is also above my pay grade, honestly, because of the folding. I saw a bunch of stuff on Reddit for that. What in the actual fucking polymers? Every time I see these arrows, thinking graphs now. What about 15? Gaiton. Isn't that the boss from Quake? Almost reached the exit of the cave, but the walls are getting closer. Submarine can barely still fit, though the main problem is that the walls of the cave are covered in chitons. Oh yeah, these look so cool. Fat. Sea cradles. Goat of milk. Seeing as my nickname is Scallop, I should do this one, huh? Another risk level. Top left, bottom right. You cannot move the what? Okay. This seems like something you can solve with a weighted graph, where your weight is the risk. I'm gonna call it quits. At least we know what's coming for us. Day 12 is gonna be brutal. Yeah, we will see. Alright, as usual, thanks for hanging out. Hope to see you next time. And have a nice end of the week, or evening, or a good night's rest, etc. See you next time. Deuces! Bye!